Assalamualaikum and a very good day to Dr. Nordin. So today I'm going to talk about three main things, which is characteristics of fluids, dimensional analysis, and also Buckingham's pi method and also Raleigh's method. So for this method, I will provide this example so we know how deeper it is. Okay, so the first one, I'm going to talk about the characteristics of fluids. So there are 7 characteristics of fluids, which is density, viscosity, temperature, pressure, specific volume, specific weight, and so specific gravity. Okay, so for the density is the ratio between mass and volume, which means the mass is in the unit of kg and volume is meter cube. So the the unit is kg per meter cube. Also, density of fluid decreases with increase in temperature and it increases with increase in pressure. So next is viscosity. So viscosity is basically the amount of resistance of the fluid to shear stress. So in a liquid, viscosity will decrease with increase in temperature, and in a gas, viscosity will increase with increase in temperature. Next is temperature. So it's the degree of hotness or coldness, and it can be measured by 3, which is Celsius, Fahrenheit, and Kelvin. So to convert between Celsius to Fahrenheit and as well as Kelvin, we have a certain number and certain converting factors so that we can convert it between the units. Next is pressure. So pressure is the force per unit area of the fluid. So force is Newton and area is meter square. So the unit is Newton per meter square. Next is specific volume. Specific volume is the volume of fluid occupied per unit mass. So volume is meter cube and mass is kg. So the unit is meter cube per kg. Specific weight is the weight possessed by unit volume of a fluid. So weight is Newton and the volume is meter cube. So we'll have units of Newton per meter cube. Next is specific gravity. Specific gravity is the ratio of specific weight of the given fluid to the specific weight of standard fluid. So it is the formula for specific gravity. So next is dimensional analysis. Dimensional analysis is the analysis of the relationships between different physical quantities by identifying their base quantities. So this is how we compare and how to make and form the formula between physical quantities and how it can relate to each other. Okay, so this is all the list. Okay, so there will be 2 method, which is Buckingham's pi theorem or method, Buckingham's pi method, and also Raleigh's method. Okay, so this is the question. So for drag force, so for the question is drag force is a function of velocity, mass density rho, mu, viscosity, and d, the diameter of sphere for fluid flow. Use dimensional analysis to determine an expression relating these variables using Raleigh's method. Okay, so this one is Raleigh's method. So first thing is we have to know the formula of the drag force and the unit of the drag force, which is m length over time square. So we'll have mlt to the power of -2. Same goes to the formula for velocity, the density, mu, and the diameter. Okay, so I have to list all these things here. So F drag force equals to F V rho mu d. So to make it a formula, so we have to put a constant here. So drag force equals to K times V to the power of A, rho to the power of B, mu to the power of C, d to the power of d. Okay, so for drag force, the formula will be, and the dimension will be mass, length, per time square, so this one, equals to, and we have to plug in, so the velocity here is length t-1, so this one here, and A, and rho, ml-3 to the power of B, ml, and for mu is ml-1, t-1, c, and ld. So this one, so we know that this one here is equals to all this, so we can do like an expression. So for m is, this one is to the power of 1, so equals to b, m to the power of b, m to the power of c. So b plus c equals to 1. So same goes to L. L is 1 here, so equals to A minus 3b minus c plus t. Okay, so here and same goes to t. Okay, so there will be 3 equations and 4 unknowns. Okay, so and we solve it here, put it here. Okay, so b equals to 1 minus c, a equals to 2 minus c, d equals to 2 minus c. So if you realize it, all is in the forms of c here. So we plug in the formula before here, here. Okay, so to this one. So k v 2 minus c, v 2 minus c, rho 1 minus c, and also mu is c and d is 2 minus c. So all in the form of c. Then we know that we have an expression here. I have to expand it and separate it to the whole number and also the coefficient of c. So k to the power of v squared times v to the power of negative c times rho negative c, and until d. Then we only left out the c form here. So the one with square, rho, and d square, we'll have to transfer it below and divide it by drag force. So this one is equals to kv negative c, blah, 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 blah. Okay, then drag force over v square rho d square equals to k, and mu over v rho d to the power of c. So this is the final answer. So to check whether it is dimensionless or not, you have to lay out all the dimension for this one: drag force, velocity, density, and also diameter here. And we have to cancel each other, and will have to and must be equals to 1, so that it will be dimensionless. Okay, so it is dimensionless. So this one is equals to this one. So if this is dimensionless, same goes to this, and this one is also dimensionless. Okay, so this is the answer. Okay, so for next method is Buckingham's pi method. It's all about the pi groups. So you have to determine the pi groups. Okay, so for that force is F equals to mu v rho d. So we have to lay out all the dimension like before the previous method. So for mu m L T v, L over t, rho m over L cubed, d equals to L. So m is all the dimensions mentioned. Mu, v, rho, d, f, d have 5 in total. And also the n is 3. Mass, length, and time that create all this formula. So to know how much pi groups that we have to solve, we have to know, have to minus m with n. So m minus n, 5 minus 3 is 2. So we know we have to solve for 2 pi groups. So how to choose is the unit is, first you have to know the geometry. Geometry is diameter. Flow is velocity, and also the fluid property, the density. So if you have 3 that the dimensions that fulfill the rules is the density, diameter, and also velocity. Okay, so the first pi group is rho x, dy, vz. So this is the 3 dimension that we choose, and we times by the drag force. Then we plug in all the formula here. Rho equals to ml negative 3 to the power of x, dl, and the same goes to until the drag force. Then we know that this one is all equals to 0. So m is x plus m to the power of 1 is equals to 0. Same goes to L, same goes to T. Then we solve the simultaneous equation. So we got x with negative 1, y equals to negative 2, z equals to negative 2. Okay, so for the first pi groups, we can arrange it. So FD, so this one is all for x. So rho to the power of x. So x is negative 1, so we put it below. And d is y, so y is negative 2, so we put it below with the power of 2, same goes to v squared. So this one is we have solved for the first pi groups, and we have to check whether it is dimensionless or not, or whether it is true or not. So we check, and it's all cancel each other, and it's equals to 1. Okay, so that's all for the first pi groups. For the second pi groups, we do the same thing. But with mu, with the mu. We times with the drag force for the first pi groups, and this one is for mu. then we solve it, then we have the second pi groups, and we check whether it is dimensionless, which is it will cancel out each other and gives 1 as an answer. So this one is how we arrange the formula, which is the first pi groups equals to f, the second pi groups. So the first pi groups we find before is fd over rho d square v square. So equals to f, we put f here, and the second pi groups to here. So mu over rho dv. So we got here the final form of for our Buckingham's pi method. So if we have more than 2 pi groups, this is how we arrange it. Means the first pi group is equals to f, second pi groups, comma, third pi groups. Okay, so if we have more than 2. Okay, so I think that's all for this video. I have explained about the characteristics of fluids, the dimensional analysis, and also the two method, Buckingham's pi method and Raleigh's method. So thank you for watching this video, and bye. Assalamualaikum.